Welcome to this specialized training module on Azure Compute. Today, we are focusing exclusively on the cornerstone of infrastructure as a service, Azure Virtual Machines. We will dissect how they function, how they connect to the network, and how to manage their storage and security. Let's start by defining what we are building. An Azure Virtual Machine, or VM, is essentially a software emulation of a physical computer. It falls under the Infrastructure as a Service, or IaaS category. When you provision a VM, you aren't buying a physical server, you are renting a slice of a physical server's capacity within Microsoft's data center. This gives you absolute control. Unlike other compute options, you manage the operating system, whether it is Windows or Linux, and you are responsible for the updates and software configurations installed upon it. This makes VMs the perfect solution when you need a specific environment for development, or when you are lifting and shifting legacy applications that require a persistent OS environment. This mind map centers on the Azure VM as the core concept. Branching out, we see it adheres to the IaaS model, meaning you rent infrastructure but manage the OS. We see flexibility in OS choices like Windows and Linux. Finally, we see common scenarios such as development, testing, and application hosting, illustrating the versatility of the service. It is helpful to think of an Azure VM as a logical construct rather than just a piece of hardware. As noted in the documentation, a VM is defined by a specific configuration: its status, CPU cores, memory, and IP address. When you click Create, Azure instantiates this logical definition by allocating the appropriate physical resources. Crucially, every VM must live inside a resource group, which serves as a logical container for managing related resources together. You must also select a region, such as East US, which dictates exactly which physical data center will house your machine. This selection impacts latency and availability. This class diagram illustrates the relationship between the VM and its management container. The resource group is the parent object. It contains the virtual machine class, which possesses attributes like size, CPU/RAM, OS type, and region. This visualizes how the VM is an object nested within your organizational hierarchy. A VM cannot exist in isolation. It needs to communicate. This is handled through the Network Interface Card, or NIC. The NIC is a standalone resource that connects your VM to an Azure Virtual Network, or VNet. When you deploy a VM, you must place it into a specific subnet within that VNet. By default, the NIC is assigned a private IP address for internal communication. If your workload requires access from the outside world, you can optionally associate a public IP address resource with the NIC. It is critical to remember that the NIC acts as the bridge. The VM doesn't connect directly to the network. It connects via the NIC. This flowchart traces the connectivity path. We start with the virtual machine on the left. It attaches to the network interface, NIC, highlighted in pink. The NIC then connects to a subnet, which is part of the larger virtual network. We also see a dotted line connecting the NIC to a public IP, indicating that external access is an optional configuration. Just like a physical server, an Azure VM needs a hard drive. Azure uses virtual hard disks, or VHD, for this purpose. Every VM comes with an OS disk, which is registered as the C drive on Windows or /dev/SDA1 on Linux. You generally should not store application data here. Instead, you attach data disks for durable storage. You can choose the performance tier of these disks: standard HDD for backups, or premium SSD for high-performance databases. All of this starts with an image, which is the template containing the OS. You can use marketplace images or capture your own custom images to standardize your deployments. This entity relationship diagram defines the storage structure. The VM entity is linked to exactly one OS disk. The OS disk is created from a source image. The VM can also have a one-to-many relationship with data disk, which allows you to expand storage capacity as needed with specific attributes like type and size. Security is paramount. To protect your VM, Azure provides network security groups, or NSG. Think of an NSG as a virtual firewall containing a list of security rules. These rules allow or deny network traffic based on direction, protocol, and port. For example, you might create a rule to allow port 80 for web traffic, but deny everything else. You can associate an NSG directly to the VM's network interface, NIC, for granular control, or to the subnet to apply rules to all VMs in that group. By default, Azure locks down inbound access, so you must explicitly create rules to let traffic in. This state diagram visualizes the traffic flow through a security group. Traffic in initiates the process. The system enters the check NSG rule state. If a rule matches allow, traffic proceeds to VM access. If it matches deny, the flow moves to drop packet, effectively blocking the connection. Managing one VM is easy, but what if you need 50? This is where virtual machine scale sets, VMSS, come in. A scale set allows you to deploy and manage a group of identical VMs. The primary benefit here is elasticity. You can configure autoscale rules to automatically add more VMs when CPU usage is high, and remove them when demand drops, optimizing your costs. Scale sets also provide high availability by distributing your VMs across different physical hardware, ensuring that if one fails, others are ready to take the load. This is the preferred method for building large-scale, resilient applications in Azure. This graph depicts a virtual machine scale set. A load balancer distributes traffic to multiple VM instances inside the VMSS scale set. An external autoscale engine monitors performance. Depending on the CPU load, it triggers actions to either plus add VM or remove VM, dynamically adjusting the size of the set. Finally, let's discuss how to deploy these resources. While the Azure portal is great for learning, you have powerful automation options. You can use PowerShell or the Azure CLI to create VMs via command line. However, for enterprise-grade consistency, you should use Azure Resource Manager, ARM, templates. These are JSON files where you define your entire environment VMs, storage, and networking declaratively. By using templates, you can deploy the exact same infrastructure repeatedly, avoiding human error and ensuring that your production environment matches your test environment perfectly. This sequence diagram shows the deployment flow using ARM. The user submits a JSON template to the Resource Manager. The manager first validates dependencies. Once validated, it instructs Azure to create the VNet and storage, followed by the virtual machine. Before reporting deployment, complete back to the user.